The distributive property. You use the distributive property when you either want to make multiplication easier, or you need to clear the parentheses and you cannot use order of operations. Here are some examples where we would use the distributive property to make multiplying easier. Let's say you need to multiply 12 times 27. You can break the 27 down to be 20 plus 7. So you can change this problem to be 12 times 20 plus 7. You're breaking it into two pieces, and then you multiply the 12 by each piece. 12 times 20, 240. 12 times 7, 84. And then you add the two pieces back together. 240 plus 84, 324. Here's another example. Let's say I had 17 times 32. I'm going to break the 32 down to be 30 plus 2. So I have 17 times 30. Well, I know that 17 times 3 is 51, so I'm just going to add the 0 back on, 510. And 17 times 2 is 34. Now I can add these two together and get 544. So what you're doing is you're breaking up the larger number into pieces and distributing the other number to the pieces. And then when you get those sums, you'll add them back together. And that's how you get your total. We really use this when we're doing mental math, okay? Because you can break it apart, keep one answer in your head, get your other answer, and add it together. If you can do order of operations, do it. It's easier. Let's say you have a problem 3 times the quantity 8 plus 5. Well, if I just looked at this problem, parentheses is the first thing I do. 8 plus 5 is 13. 3 times 13 is 39. That's how you should do that type of problem, okay? Order of operations is just easier. What if I have negative 5 times the quantity 3 minus 14? Well, 3 minus 14 is negative 11, and I know negative times negative is positive. Negative 5 times negative 11, positive 55, okay? You could use the distributive property with this, but it's more work. So if you can do order of operations, always do that first. But what if order of operations won't work? Let's say you have a problem like this example. 3 times the quantity x plus 5. You cannot add x and 5 because they are not like terms. One is a variable, one is a number, okay? So what we do is we distribute or multiply, like we did before when we broke our numbers up. We multiply the number outside the parentheses with every number inside of the parentheses. In this example, there's just 2, but there could be 3 or 4 or 5. There could be a whole bunch, okay? But it's very important that you pay attention to the signs of the numbers. So back to our example, 3 times the quantity, x plus 5. 3 times x, well, it's just 3x. And 3 times positive 5 is positive 15. That's our answer. We're done. It's pretty easy. Here are some more examples where we really have to pay attention to the signs now, okay? Let's say we have negative 2 times the quantity x plus 8. Negative 2 times x is negative 2x, and negative 2 times positive 8 is negative 16. Because remember, when the signs are different, you get a negative in multiplying or dividing. Okay, so I said negative 16, and I wrote down negative 16, but that's the term. When I look at this as an answer and just read it, I would say negative 2x minus 16. Here's another example. 4 times the quantity, 2n minus 8. Now in this example, I can multiply the 4 times 2, but it's 4 times 2n, so I multiply the 4 times 2 part of it and get 8, but it's really 4 times 2n, so it's 8n. 4 times negative 8, negative 32. I want you to say the answer is positive or negative because that tells you if you should put down a minus sign in the 32 or a plus sign in the 32, okay? How about negative 6 times the quantity, negative x minus 5? Negative 6 times negative x. Negative times negative is a positive. And then 6x times x is just 6x. What about negative 6 times negative 5? Once again, negative times negative is a positive. So negative 6 times negative 5 is positive 30. Okay, I just wrote down positive 30, but when I look at my answer, it's 6x plus 30. All right? So you really need to think about the signs when you're multiplying now. We're not making everything addition signs like we used to, okay? All right, here are some examples using area with the distributive property. Here's a rectangle, and I know it's a rectangle because these sides are the same and these sides are the same. I can tell by the tick marks, and it's 90-degree angle. So the length is 3n minus 2. The width is 5. When you are finding area, you always write down the formula. Area equals length times width. Then we substitute. So, remember how I said this was the length? But that's not what I wrote. I changed the order. I wrote 5 times the quantity 3n minus 2. Well, I can change the order in multiplication because of the commutative property. So I'm going to do it because this is, I like to multiply going from left to right. And that's how I'm teaching you to do it. So you need to use the properties that you learn to make the problem easier for you, okay? If it's in the book written the other way, you can rewrite it the way you want it because you know you can do the commutative property. So 5 times 3n is 15n. 5 times negative 2 is negative 10. Now, this says UN squared. UN is the abbreviation of units. Did you notice I didn't tell you what the units are here? You don't know if they're centimeters or inches or miles. That'd be huge, wouldn't it? So if I don't tell you, or if the book doesn't tell you, in your answer you write unit squared because area always needs a measurement. Here's another shape, a square. Because all sides are the same, you can tell by the tick marks, and there's a 90-degree angle. So this side is 2x plus 5, and this side is 11. What must 2x plus 5 equal? 11, huh? Because it's a square. But anyhow, I'm going to write the formula, area equals length times width. I'm not going to write side squared because I didn't give you the sides the same. And I'm going to write 11 times the quantity 2x minus 5, 5, because I like to multiply going from left to right. 11 times 2x, 22x. 11 times positive 5, positive 55 units squared. All right, now we have two triangles. This first triangle looks like a scalene triangle. I didn't put any marks on it, so I can't tell, but it's definitely not a right triangle. All right, the base is 20. The height is 2x plus 15. Area, formula of a triangle, area equals 1/2 times the base times the height. So 1/2 times 20 times 2x plus the quantity 2x plus 15. Now if these were switched, I would still write the 20 next to my half, because right now I'm giving you nice numbers that are evenly divisible by 2, so you can take half of them, but later I'll explain to you how to take half at the end if it's not. But right now I want to do half of 20 is 10. And then 10 times the quantity 2x plus 15. Now I need to use the distributive property, so I get 20x plus 150 units squared. Where kids make mistakes in this is they sometimes think that they need to do 1/2 times 20 and then 1/2 times 2x plus 15. You only do the distributive property when you have one number next to your parentheses, a 10. Because when you're multiplying three numbers together, you do it like this. Let's say I have 3 times 2 times 5. When I have three numbers I'm multiplying, I multiply 2 together and get a new number. 3 times 2 is 6. 6 times 5, 30. What if I wanted to multiply other numbers? What if I had, let's do it again, 3 times 2 times 5. What if I wanted to multiply 2 times 5? Because that's a nice number. So I could say, okay, so 3 times 10. And then 3 times 10 is 30. Notice I do not say 3 times 2 and 3 times 5 and, make a big mess. I multiply 2 together. That's what I do here. Okay, so don't make that mistake. You only distribute one when you have one number in front of your parentheses. Okay, you have to do other work to get that. All right, here's a right triangle. Base is 5x minus 14. Height is 14. Oh, that's not 5x minus 14. 5x minus 8, I'm sorry, and 14. So the formula is area equals 1/2 base times height. Now notice 1/2 base, but I'm using the commutative property. I'm plugging in my 14, so I can take half of 14 pretty easily. 1/2 times 14 times the quantity, 5x minus 8. Half of 14 is 7. 7 times the quantity, 5x minus 8, gives us 35x minus 56, because 7 times negative 8 is negative 56. Once again, units squared. That's it.